Hey everyone, and welcome to another deep dive.
Yeah.
Today we're going to be tackling a topic that's as fascinating as it is complex: asteroid mining.
It truly is fascinating.
We've got a treasure trove of sources to guide us.
Oh, yeah. Like what?
We've got Wikipedia, some really in-depth research papers, and even some audio discussions from experts in the field.
Sounds like we're well equipped for this journey.
Exactly. Because to really grasp asteroid mining, we need to consider its sheer scale.
Hmm.
We're potentially talking about a trillion-dollar industry that could redefine humanity's future.
It's mind-boggling when you think about it.
Absolutely. But where do we even begin? That's what we're here to explore.
One of the things that really captivates me about asteroid mining is how it blurs the line between science fiction and reality. This isn't just some newfangled idea. It's a concept that's been simmering in our collective imagination for decades.
You're right. It's like those early sci-fi authors were planting seeds, envisioning these grand cosmic adventures long before we even set foot on the moon.
Exactly. Think about books like Scavengers in Space from 1959 or Miners in the Sky. They were already exploring the motives and potential dangers of asteroid mining back then.
It's amazing how those early works foreshadowed so many of the discussions we're having today.
It really is.
So this concept has been around for a while, but then, boom. Events like the Apollo 11 landing in 1969 made space exploration a reality. Suddenly, venturing beyond Earth wasn't just a fantasy, it was an achievement.
It was a pivotal moment that shifted our perspective, and it absolutely propelled asteroid mining from the realm of fiction towards something we could actually consider pursuing.
It makes sense. That era sparked so much scientific interest. Researchers began to look at nearby asteroid groups like the Apollos and Amors. I guess it seemed logical to start with the ones closest to Earth.
Absolutely. There was an initial assumption that these asteroids were teeming with easily accessible resources.
Makes sense. Start close, test the waters.
Yeah.
But as our understanding of the solar system evolved, the focus shifted in the 1980s to the moons of Mars, Phobos and Deimos. What prompted that change?
Well, we realized that proximity isn't everything. While those nearby asteroids were easier to reach, they might not have been the most resource-rich.
I see. So it was kind of like upgrading our cosmic toolkit and expanding our horizons, right?
Exactly. Advancements in technology and our understanding of the solar system opened up exciting new possibilities further out.
Okay, so we've talked a bit about the when and the where, but I think it's crucial to pause and address the big why. Why should our listeners care about asteroid mining? This isn't just some far-off space race or a quest for more stuff, right?
Definitely not. This has the potential to solve some of the most pressing issues facing humanity right here on Earth.
You're talking about resource scarcity.
Exactly. As our population grows and technology advances, we're putting an immense strain on Earth's resources. Some experts believe we're on a path toward overconsumption and depletion.
And that's where those resource-rich asteroids come into play, like cosmic treasure chests filled with metals, water, and other things we desperately need.
Precisely. Imagine a metallic asteroid packed with enough platinum to power all of Earth's energy needs for a century.
Wow. That's a game changer. It makes you realize how asteroid mining could revolutionize renewable energy and push us towards a more sustainable future.
Absolutely. And it goes even deeper than that.
How so?
It ties into the long-term survival of our species. Asteroid mining isn't just about sustaining life on Earth, it's about enabling humanity to become a multi-planetary species.
So it's like a cosmic insurance policy for humanity.
In a way, yes. It's about ensuring that if something catastrophic were to happen to our home planet, we'd have a backup plan, a way to continue our story beyond Earth.
That's a powerful thought. But let's face it, this stuff is hard, right? We're talking about operating in one of the most extreme and unforgiving environments imaginable.
Absolutely challenging. Just look at the missions we've already sent to asteroids. Returning even tiny samples has been incredibly complex and expensive. Hayabusa, Hayabusa 2, OSIRIS-REx.
Groundbreaking missions, but how much material did we actually get back?
All those missions combined, we've only managed to bring back about 127 grams of asteroid material.
127 grams. That's less than a cup of coffee.
It is. And the cost. The most recent mission, OSIRIS-REx, cost a staggering $1.16 billion.
So if retrieving a tiny bit of space dust costs that much, scaling up for actual mining seems daunting, to say the least. What are the biggest technological hurdles?
Well, for starters, developing robots that can function reliably in the harsh conditions of space. Extreme temperatures, radiation, micrometeoroids whipping around at insane speeds.
It's like sending a Roomba into a cosmic demolition derby.
Pretty much. These robots need to withstand all that while performing complex tasks like drilling, excavating, and processing materials.
But haven't there been some huge advancements in robotics and AI that could help overcome these challenges?
Definitely. The field is constantly evolving, with researchers developing increasingly sophisticated robots, but the space environment is relentless, ensuring their reliability remains a top priority.
So it's a constant push and pull between innovation and the unforgiving realities of space. But let's say we've mined the materials. How do you even capture and contain them in zero gravity?
That's where things get really ingenious. Engineers are working on innovative capture mechanisms, some using cables to secure a rotating cutter head against an asteroid.
So like a giant spacefaring snowblower gathering up regolith.
Precisely. And then, of course, we have the mammoth task of transporting those mined materials back to Earth or wherever they're needed.
Yeah, that can't be easy.
The logistics are mind-boggling. Massive spacecraft, powerful propulsion systems, incredibly precise navigation. And the time factor. These missions could take years, even decades to complete.
Okay, so this is clearly a long-term vision, not some quick fix. But as we've said, the potential payoffs are massive, making it a journey worth embarking on. Speaking of journeys, who are the key players making asteroid mining a reality?
Well, it's a fascinating mix of governments and private companies, each playing a crucial role.
Like who?
On the government side, Luxembourg is making big investments to become a hub for asteroid mining.
Really? Luxembourg?
Yes, they're creating legal and regulatory frameworks and offering incentives for companies to set up shop in their spacefaring nation.
So they're positioning themselves as a sort of cosmic Silicon Valley for asteroid mining. What about other governments? Any international collaborations?
International cooperation is essential for any large-scale space endeavor. The United States, for instance, has already passed laws allowing for the private ownership of space resources.
Hold on. Private ownership of space resources, isn't that a bit controversial?
It certainly raises some eyebrows, legally and ethically. The Outer Space Treaty of 1967, which is the cornerstone of international space law, prohibits countries from claiming ownership of celestial bodies. But some argue that it doesn't explicitly prevent individuals or corporations from owning resources extracted from those bodies. It's a legal gray area ripe for debate as space exploration evolves.
That's a thought-provoking point. It seems like the laws governing space need to catch up to our ambitions. But let's shift gears to the private companies driving innovation in this field. Who are the big names?
Well, there are some incredible companies pushing the boundaries. Companies like Planetary Resources, Deep Space Industries, the Asteroid Mining Corporation.
These aren't just names. They represent real people dedicated to making asteroid mining a reality.
Absolutely. Passionate individuals, brilliant engineers, visionary entrepreneurs.
It's inspiring to see that kind of dedication. And speaking of blurring the lines between science fiction and reality, I read that Planetary Resources initially wanted to fund their venture through crowdsourcing.
It's true. They envisioned a future where everyday people could contribute to a cosmic mining operation. It didn't quite materialize that way, but it highlights how asteroid mining captures the public's imagination.
It's like a democratization of space exploration, where everyone can potentially have a stake in the future. Okay, let's zoom in on the asteroids themselves. Are they just generic chunks of rock, or is there more to them?
Asteroids are incredibly diverse, each with its own unique composition and potential value. They're like a cosmic buffet of resources. We broadly categorize them into three main types: C-type, S-type, and M-type asteroids.
Okay, break it down for us. What makes each type special?
Well, C-type asteroids are the most common. They're rich in water, which is incredibly valuable for future space exploration.
Like cosmic gas stations for our interplanetary road trips.
Exactly. They're also rich in organic carbon and phosphorus, essential elements for growing food. Imagine space farming, cultivating crops on asteroids to sustain long-duration missions, or even establish settlements.
That's taking farm to table to a whole new level. What about those S-types, the ones that get the prospectors excited?
S-type asteroids are the ones with the bling. They contain precious metals like nickel, cobalt, gold, platinum, and rhodium.
A potential gold mine in space. How much are we talking about?
Imagine this. A small 10-meter S-type asteroid could contain a whopping 650,000 kilograms of metal.
That's just mind-blowing. And lastly, the M-types, the rare ones.
The M-types, the high rulers of the asteroid world. They're the rarest, but they can contain up to 10 times the metal content of the S-types.
Now that's what I call striking it rich. So we've covered the what and the why. But how do we actually mine these asteroids? Are we talking astronauts with pickaxes chipping away at space rocks?
Not quite. While that image is amusing, the actual methods are far more sophisticated. Engineers are exploring a range of options, each with its own set of challenges and benefits.
Okay, I'm all ears. What's in the asteroid mining toolkit?
There are four main approaches. In-space manufacturing, bringing raw materials back to Earth, processing materials on site, and then there's a truly audacious idea of transporting an entire asteroid into a safe orbit.
Whoa, hold on. Transporting the whole asteroid. That's straight out of science fiction.
It is a bold concept, but it highlights the scale of ambition in this field. Each approach has its own unique hurdles and potential benefits.
All right, let's unpack these approaches. In space manufacturing, sounds like something straight out of Star Trek.
It's been a dream for a long time. Imagine building habitats, solar power stations, even spacecraft components, all right there in space, using materials extracted from asteroids.
It's like setting up a cosmic construction yard, right?
Exactly. It would revolutionize space exploration. We could create a more permanent presence beyond Earth without relying solely on supplies from home.
But what about the initial setup? Wouldn't we need to send a massive amount of equipment up there to kickstart this space-based industrial revolution?
The initial investment would be substantial. We'd need to launch robots, 3D printers, power sources, all the materials for these space-based factories. A logistical feat of epic proportions.
It's like bootstrapping an entire industrial revolution in space. Okay, let's talk about bringing raw materials back to Earth. Seems straightforward, but what are the challenges?
The sheer cost and energy required for transport. Imagine hauling millions of tons of asteroid ore across millions of miles. We'd need fleets of massive spacecraft, each guzzling fuel. And even with advanced propulsion, the round trip could take years, even decades.
So even if we can mine the asteroids, getting those resources back to Earth efficiently and cost-effectively is a big hurdle. What about processing the materials on-site?
Now that's where things get super innovative. Think of self-contained mini-refineries operating autonomously on asteroids.
So instead of shipping the whole haystack back to Earth, we're extracting the needles right there on the asteroid.
Exactly. It's all about efficiency and maximizing resource utilization. Plus, it reduces the environmental impact of hauling all that material back to Earth.
Okay, let's talk about that crazy idea of transporting an entire asteroid into a safe orbit. How do you even begin to move something that massive? We're not talking about nudging a pebble here. We're talking asteroids that can be miles wide.
We're talking about harnessing the power of gravity, sunlight, even nuclear energy. Technologies like gravity tractors, solar sails, ion engines, and nuclear propulsion systems are all on the table.
Those sound like concepts straight out of a science fiction movie. Are we even close to making those a reality?
Some of these technologies are already in development and have been tested on smaller scales. Take the gravity tractor, for example. It uses a spacecraft's gravitational pull to gently nudge an asteroid into a different trajectory over time.
It's like playing cosmic billiards with asteroids. What about those other ideas?
Well, solar sails use the pressure of sunlight to propel a spacecraft, kind of like the wind pushes a sailboat. They're a clean and efficient way to travel long distances in space. Then there are ion engines, which use electricity to accelerate ions, creating thrust. While they produce low thrust, they can operate for a really long time, gradually building up speed.
So it's a case of slow and steady wins the cosmic race. And nuclear propulsion.
Nuclear propulsion offers more power, but also comes with greater risks and ethical concerns. Using nuclear reactions to generate thrust could significantly shorten travel times. However, safety and the potential environmental impacts are major concerns.
So it seems like each option has its own pros and cons. What a fascinating array of possibilities. But even with all this amazing technology, there's still the human element. What role will humans play in all of this? Will it be all robots and AI, or will we always need that human touch?
Robots and AI will be crucial, especially in those dangerous environments. But humans will always be essential for oversight, decision-making, and especially for handling unexpected situations. Space is full of surprises.
So it's not just about building smarter robots, it's about designing better human-robot interactions. How do we make that work millions of miles away in the harshness of space?
Teleoperation is one exciting area. Imagine humans on Earth remotely controlling robots on asteroids, using virtual reality and haptic feedback to make it feel like they're actually there.
That's incredible. But what about those communication delays? Wouldn't those make real-time control impossible?
That's the biggest obstacle. Sending signals across vast distances takes time, sometimes minutes or even hours, which makes real-time control a huge challenge.
So it's not as simple as pressing a button and seeing an immediate response. You need to think way ahead and anticipate problems before they happen.
Exactly. Operators would need to be incredibly strategic, developing contingency plans for those inevitable space surprises. And that's where autonomous systems become crucial. Allowing robots to make certain decisions independently frees up human operators to focus on the bigger picture and those critical moments that require human intuition.
So a truly collaborative effort, pushing the limits of human ingenuity and robotic capabilities, it's amazing.
It is. It's a testament to the incredible potential of humans and machines working together to achieve something truly remarkable. Welcome back, everyone. Let's shift gears and really get into the nitty-gritty of asteroid mining. Let's talk about the extraction process itself.
I'm ready. Last time we were talking about the four main approaches to asteroid mining.
Yeah,
In-space manufacturing, bringing raw materials back to Earth, processing materials on-site, and that mind-blowing idea of transporting a whole asteroid into orbit.
right. And each of these methods has its own set of technological challenges. Let's start with in-space manufacturing. It sounds like something straight out of science fiction, doesn't it? Building habitats, power stations, maybe even spacecraft components, all right there in space, using materials we get from asteroids.
It's like setting up a cosmic construction yard. No more relying on Earth for everything. We could build a sustainable presence in space.
Exactly. In-space manufacturing could completely change how we approach space exploration, enabling us to build a lasting presence out there.
It's incredible. But I'm curious about the logistics. To set up these space factories, wouldn't we need to send up a ton of equipment?
Oh, absolutely. The initial investment would be huge. Robots, 3D printers, power sources, all the materials for these factories.
It's like bootstrapping a whole industrial revolution in space.
It is. We're talking about a long-term vision here, investing in a future where we're not just visiting space, but actually living and working there.
Makes sense. Okay, what about bringing those raw materials back to Earth? It seems like the most straightforward approach, but are there challenges?
The biggest one is the cost and the energy it would take to transport all that material. We're talking millions of tons of asteroid ore across millions of miles of space.
That's a long way to haul rocks.
It is. We'd need fleets of huge spacecraft and all that fuel. It could take years, maybe even decades, for a round trip.
Wow, so even if we can mine the asteroids, actually getting those resources back to Earth efficiently and in a way that makes financial sense is a major hurdle.
Definitely a challenge.
What about processing the materials right there on the asteroid?
Now that's where things get really exciting. Imagine having these self-contained, miniaturized refineries operating right on the asteroid. They would extract valuable metals and resources without having to ship all that bulky raw material back to Earth.
So instead of bringing back the whole haystack, we just take the needles.
Right.
That's brilliant. It seems much more efficient and would minimize waste.
Exactly. And it's much better for the environment than hauling tons of rock back to Earth.
All right, let's talk about that most audacious approach, transporting an entire asteroid into a safe orbit.
Yeah.
How do you even begin to move something that massive? I mean, these aren't little pebbles. We're talking asteroids miles wide.
It's a wild idea, right? But we're talking about harnessing some seriously powerful forces. Gravity, sunlight, even nuclear energy. We're looking at technologies like gravity tractors, solar sails, ion engines, and even nuclear propulsion systems.
Those sound like they're straight out of a science fiction movie. Are these technologies even possible?
Some are already being developed and tested. The gravity tractor, for example, it uses a spacecraft's own gravity to very slowly pull an asteroid into a different orbit.
It's like playing a slow-motion game of cosmic billiards, using gravity to guide the asteroid where we want it.
It is. Then you have solar sails, which use the pressure of sunlight to push the spacecraft forward like a sailboat. Ion engines use electricity to accelerate ions and create thrust. They might not be super powerful, but they can run for a long time, gradually building up speed.
So slow and steady wins the cosmic race. What about nuclear propulsion? That one seems a little more intense.
It is. Nuclear propulsion would give us a lot more power, but also comes with more risks. It uses nuclear reactions to generate thrust, which could shorten travel times, but there are big concerns about safety and potential environmental impacts.
It seems like every option has its own set of benefits and risks. It's incredible to see so much creativity and innovation going into this field.
It really is. Asteroid mining is pushing the boundaries of what we thought was possible.
But even with all these incredible technologies, we can't forget the human element. What role will humans play in asteroid mining? Will it be all robots and AI?
Robots and AI will definitely be vital for those dangerous and demanding tasks, but humans will always be needed. We need human oversight. We need people who can solve problems on the fly, and especially when something unexpected happens, which it always does in space, we need that human ability to adapt and think creatively.
So it's not just about building smarter robots, it's about creating a partnership between humans and machines. A partnership where both sides use their strengths to overcome the challenges of asteroid mining.
Exactly. It's a real testament to the power of collaboration, how humans and machines can work together to do something truly extraordinary.
Absolutely. But how will that collaboration work in practice, especially considering the harsh conditions of space?
One promising area is teleoperation. Imagine humans on Earth controlling robots on asteroids, using virtual reality and haptic feedback to make it feel like they're really there.
It's like stepping into the robot's shoes and experiencing everything firsthand, even though you're millions of miles away.
That's the idea. But of course, communication delays are a huge challenge. Those signals have to travel a long way, so real-time control is pretty much impossible.
So it's more about planning ahead, anticipating what might happen, and being prepared for anything, right?
Exactly. It's like playing a game of cosmic chess, where every move needs to be carefully considered because the consequences might not be clear for hours or even days.
So we need operators who are strategic thinkers, who can think several steps ahead.
Absolutely. And that's where autonomous systems come in. Giving robots the ability to make some decisions on their own will allow human operators to focus on the big picture and those moments that need human intuition.
So it's a partnership that requires the best both worlds. The strategic thinking and adaptability of humans, combined with the precision and resilience of robots.
Exactly. And it's that partnership that will allow us to overcome the incredible challenges of asteroid mining. It's a testament to our ambition, our ingenuity, and our desire to push the boundaries of what's possible.
I completely agree. It's a really inspiring example of what we can achieve when we combine human ingenuity with cutting-edge technology. All right, we've explored the different approaches to asteroid mining, the technologies involved, and even touched on the human-machine collaboration that will be so essential for success. But before we wrap up, I think we need to dive into the heart of the operation, the extraction process itself. How do we actually get those precious resources out of an asteroid?
Well, the methods will vary depending on what type of asteroid we're dealing with and what resources we're after. For C-type asteroids, which are rich in volatiles like water, we might use heat to extract them, almost like baking them out.
A giant cosmic oven.
Something like that. And then for those metal-rich S-type asteroids, we might need to adapt traditional mining techniques, things like drilling, blasting, and excavating. But they'll need some serious modifications to work in space.
I can imagine. Microgravity in a vacuum present some unique challenges.
They do. We can't use explosives that rely on oxygen, for example. And dealing with dust clouds in microgravity is a whole other issue. Dust can cause all sorts of problems for equipment and human health.
It makes sense. We have to be mindful of the impact we're having, even in the vastness of space.
Absolutely. Sustainable mining practices are crucial no matter where we're operating. We need to make sure we're minimizing harm and preserving the integrity of these celestial bodies.
So we extract the materials, but then what? Where do they go? How are they processed and used?
Well, that depends on the approach we take. If we're bringing raw materials back to Earth, they'll be processed using the infrastructure and technologies we already have.
So we'd be integrating these space-sourced materials into our existing systems.
Exactly. If we process materials on-site, we might refine them into more valuable products right there on the asteroid. Less transportation, less waste.
It's all about optimizing every step of the process.
It is. And then, of course, there's the possibility of using those resources to manufacture goods directly in space.
Now that's a futuristic thought. Imagine having factories on asteroids, making spacecraft parts, habitats, all sorts of things.
It's a vision that's becoming more and more achievable as technology advances. Asteroid mining could open up a whole new era of space exploration, one where we're not just visiting, but building and expanding our presence in the cosmos.
It's an inspiring vision. It shows what's possible when we combine human ingenuity with technological innovation. It's about pushing the boundaries and creating a future where humanity can thrive beyond Earth.
Absolutely. But as with any ambitious endeavor, there are risks and challenges to consider. We've talked about the technological hurdles, the logistics of operating in space, and the ethical questions around resource ownership and environmental impact.
Those are certainly big challenges, but they also represent opportunities for growth and collaboration.
I agree, we can overcome these challenges, but we need to be in it for the long haul. It requires commitment to international cooperation, the willingness to learn and adapt as we go.
It's a reminder that space exploration isn't a solo mission. It's a team effort. We need to work together, sharing knowledge and resources to make this vision a reality. But beyond those practical considerations, I'm curious about the bigger picture, the philosophical implications of asteroid mining. How might it change how we see ourselves and our place in the universe?
That's a great question. I think asteroid mining could fundamentally change our perspective on humanity's role in the cosmos. For so long, we've seen ourselves as Earthlings bound to this planet. But as we start venturing out, harnessing resources from other celestial bodies, our perspective widens.
So instead of just looking up at the stars, we become active participants in the grand cosmic drama.
Exactly. We become citizens of the solar system, maybe even the galaxy. And as we explore, we'll encounter new challenges, make new discoveries, gain new perspectives. It'll be a journey of exploration, innovation, and self-discovery. And asteroid mining could be the thing that launches us on that incredible journey, opening up a universe of possibilities for generations to come.
Welcome back, deep divers. In the previous parts, we really dug deep into the history, motivations, and the sheer scale of ambition when it comes to asteroid mining.
It's been quite a journey so far, and it's clear that what was once a concept confined to science fiction is rapidly transitioning into a tangible reality.
A reality with immense implications for the future of humanity, I might add.
Absolutely. We're potentially talking about a trillion-dollar industry, a complete game changer for our economies, our technologies, and even how we see ourselves as a species.
It really forces us to think big, to consider the trajectory of human civilization on a grand scale.
It does.
It's almost like those early explorers setting sail across uncharted oceans. But instead of new continents, we're discovering a new frontier of resources and possibilities in space.
I love that analogy. And just as those early voyages led to enormous shifts in trade, technology, and global power, asteroid mining has the potential to reshape our world in ways we can't even fully grasp yet.
It's exciting and a bit daunting at the same time. So let's talk about those potential impacts. What are some of the most significant ways asteroid mining could reshape human civilization?
Well, one of the most immediate impacts could be on the global economy. Imagine a sudden influx of precious metals, things like platinum and gold coming from asteroids.
What would that do?
It could completely disrupt existing markets, create entirely new industries, and potentially shift the balance of economic power.
It's amazing to think about the ripple effects. Asteroid mining could lead to incredible economic growth, but also potential instability.
Exactly. We've seen throughout history that discovering new resources can lead to booms and busts, fortunes made and lost. We need to manage this transition carefully, making sure the benefits are shared equitably and avoiding the problems that come with uncontrolled exploitation.
It reminds us that new technologies often come with ethical and social challenges that we need to consider carefully.
I completely agree.
So beyond those economic impacts, how could asteroid mining influence technological innovation back here on Earth?
Well, imagine having a readily available supply of resources that are scarce here on Earth. It could revolutionize manufacturing, lead to all sorts of new technologies, and even help us solve some of our biggest challenges, especially in areas like energy and resource management.
So many possibilities. It's like opening up a treasure chest of opportunities for scientists, engineers, and entrepreneurs.
Precisely. For example, think about platinum group metals. They're essential for clean energy technologies like catalytic converters and fuel cells. Having a large supply of these metals from asteroids could help us transition to a much more sustainable energy future.
That's incredible. Asteroid mining could be a vital part of our efforts to combat climate change and create a better future. But it's not just about solving problems here on Earth, right? It's also about pushing beyond our planet and taking those first steps toward becoming a multi-planetary species.
Absolutely. Asteroid mining could be the key to establishing a permanent human presence in space. Think about using those resources to build habitats, fuel depots, entire settlements on other planets or moons.
It's like the ultimate form of off-grid living. We wouldn't have to rely on Earth for everything. We could use the resources of space to sustain ourselves.
Exactly. It's about creating a self-sufficient system where we reuse and recycle resources, minimize our impact, and ensure that we can exist sustainably in space.
It's an amazing vision of a future where humanity not only survives but thrives among the stars. We'd be using our ingenuity and technology to make a new home for ourselves out there.
Yeah,
But of course, there are also challenges and risks, right?
there always are. No great endeavor comes without hurdles, and asteroid mining is no exception. We've already discussed the technological complexities, the logistical nightmare of operating in space, and the ethical concerns around who owns those resources and what impact we'll have on the environment.
Those are big challenges, but it seems like they also represent opportunities for innovation and global collaboration.
They absolutely do. These challenges aren't insurmountable, but they need a long-term commitment. We need international cooperation and the willingness to keep learning and adapting as we go.
It's a reminder that space exploration isn't a solo mission, it's a global endeavor. And we need to work together, sharing knowledge and resources if we want to succeed. Okay, I want to shift gears a little and talk about the philosophical side of things. How could asteroid mining change our understanding of humanity's place in the universe?
That's a fascinating question. I think asteroid mining has the power to fundamentally change our perspective on who we are and where we fit in the grand scheme of things.
How so?
For centuries, we've been stuck on Earth, looking up at the stars. But when we start venturing out, using the resources of other celestial bodies, our perspective expands. We're no longer just inhabitants of Earth. We become citizens of the solar system, maybe even the galaxy.
It's like we go from being passive observers to active participants in the universe.
Exactly. And as we explore, we'll encounter new challenges, new discoveries, and new perspectives. It'll be a journey of growth and self-discovery. And asteroid mining could be the catalyst, the thing that launches us on that incredible journey and opens up a universe of possibilities for generations to come.
It's a powerful vision. So as we wrap up this deep dive into asteroid mining, what are some of the key takeaways you hope our listeners will remember?
Well, first, I hope they grasped the sheer scale of this endeavor. We're talking about something that could completely transform human civilization and propel us into a new era of space exploration. It requires bold thinking, technological innovation, and a willingness to face the unknown.
It's a testament to our human spirit of exploration, our drive to push the boundaries of what's possible.
Absolutely. Second, I hope they understand that asteroid mining is a journey, not a destination. It will take decades of effort, innovation, and collaboration. There will be setbacks, challenges, and surprises along the way, but the potential rewards are so immense that it's a journey worth undertaking.
It's about taking risks, learning from our mistakes, and never giving up on the dream of reaching for the stars. What about the ethical and societal implications? What's the most important thing for us to remember?
We need to have open and honest conversations about these issues. We need to make sure asteroid mining benefits everyone, not just a select few. Sustainability and environmental responsibility must be at the forefront of everything we do in space. And we need to approach this new frontier with a sense of wonder, humility, and respect for the universe we are part of.
Well said. Those are powerful reminders that as we venture out into space, we have a responsibility to act ethically, sustainably, and for the benefit of all humankind. It's about building a future where humanity can thrive beyond Earth while staying true to our values and the best of what it means to be human.
Couldn't have said it better myself.
So, to our listeners, as we conclude our deep dive, we leave you with this final thought. How will asteroid mining, as it moves from concept to reality, shape your life? Will we one day see products made from asteroid materials on our store shelves? Will we travel in spacecraft built with those resources, or even live in habitats constructed on other worlds? The future is unfolding before us, and it's full of incredible opportunities and responsibilities. Keep exploring, keep asking questions, and keep diving deep into the wonders of the universe.